Hello students, welcome to Educate. Today we are going to do numericals of chapter 8 of class 12 physics. So let's start. The first question is figure 8.5 shows a capacitor made up of two circular plates, each of radius 12 centimeter and separated by 5 centimeter. The capacitor is being charged by an external source not shown in the figure. The charging current is constant and equal to 0.15 ampere. Calculate the capacitance and the rate of change of potential difference between the plates. Obtain the displacement current across the plates. Is Kirchhoff's first rule, that is junction rule, valid at each plate of the capacitor? Explain. So you have already studied the expression for capacitor. So capacitance C is equal to epsilon naught A divided by D. Now we can put the values 8.85 into 10 to the power minus 12 into plate area. Plate area here radius is 12. So pi into 0.12. So let's write it here. So into 22 by 7 into 0.12 whole square epsilon naught A divided by D. D is plate separation and plate separation is 5 centimeters. So 5 into 10 to the power minus 2. Now we can evaluate it. So after evaluation, just give 1 minute. It will come out to be 80.1 into 10 to the power minus 12 farad or 80.1 picofarad. So this is answer to first part. Second one, obtain the displacement current across the plate. Displacement current is same as conduction current. So we can find its expression. Here current is given as 0.15 ampere. So you can say displacement current ID will be equal to IC, which will be same 0.15 ampere. Then next part is Kirchhoff's rule, first rule, junction rule valid? Yes, of course, it will be valid. If you remember, I have told you that current will be equal to IC plus ID. When we have modified, we have written formula integration B dot dl modified Ampere circuital law. So it is mu naught then IC plus ID. So Kirchhoff's junction rule is valid, right? Now we are going to see next question. Next question says we are given certain information. A parallel plate capacitor made of circular plates each of radius r equal to 6 centimeter has a capacitance C equal to 100 picofarad. The capacitor is connected to a 230 volt supply with angular frequency of 300 radian per second. So we can note the information and then we can proceed. So related information, R is given as 6 cm, then capacitance is given C equal to 100 picofarad, and applied voltage V is given as 230 volt, right? Angular frequency is also given, omega equal to 300 radian per second. Now we have to find out here what is to be found. What is RMS value of conduction current? Is the conduction current equal to the displacement current? Determine the amplitude of B at a point 3 centimeter from the axis between the plates. So it is simple, so we can evaluate it. So let's try. So first of all, we need IRMS. So IRMS will be equal to VRMS divided by XC, and this will become VRMS into XC is, if you remember, XC is given by 1 upon 2 pi FC. So this will become 2 pi FC. Then we can put the values. VRMS is given and frequency is also given. 2 pi f is directly given, which is omega, and C is given. So we can put the values. So if we put the values, so all values you can place here. So after that you will get 6.9 into 10 to the power minus 6 ampere, or you can say 6.9 micro ampere. Is there any problem in placing the value? I don't think so, because it is simple. And second part is the conduction current equal to displacement current? Yes, IC equal to ID. We have also proved, because if you remember, I told you how to prove it. We can consider the expression for, so displacement current is given by epsilon naught d phi e divided by dt, and phi e from Gauss law, it is q upon epsilon naught. So if we write it here, we are starting with displacement current id. So epsilon naught d upon dt of q upon epsilon naught. So what do we get? Epsilon naught will cancel out, dq upon dt, and you know dq upon dt is just conduction current. So we can say that both are equal. Then next point is, what does it say? Determine the amplitude of B at 3 cm from the axis. So here we have to consider the expression for B. So we can write the relation for B as B equals mu naught divided by 2 pi times distance divided by radius square into current. So whatever current is there, IT, displacement current, right? Here we are given value of distance is 3 centimeter, and the radius is also given, and ID we have evaluated. So we have got just IRMS. So IRMS we have got as 6.9 milliampere. It was not milli, it was microampere. And suppose we find its maximum value, that will be ID, and that will be equal to 6.9 into root 2 microampere, right? So this value we can put here. So B will be mu naught upon 2 pi, which will be 2 into 10 power minus 7. Do you remember mu naught upon 4 pi equal to 10 power minus 7? So mu naught upon 2 pi 2 into 10 power minus 7. R is 3 centimeter, 0.03, and the capital R, the radius was given as 6 centimeter. So we can write it 0.06 square, and then this value 6.9 into 10 root 2 into 10 to the power minus 6. So we can simplify it. Simplification, you know. So after evaluation, you will get 1.63 into 10 to the power minus 11 Tesla. Now, let's consider next question. Question says, what physical quantity is same for the X-rays of wavelength 10 power minus 10 meter, red light of wavelength 6800 angstrom, and radio waves of wavelength 500 nanometer. So if you remember, the speed of light for all type of radiations is the same. So here our answer will be speed of EM waves, and the speed of EM waves C is equal to 3 into 10 to the power 8 meter per second. So answer to 8.3 is this. Sorry. Now let's see next question. Next question says, a plane electromagnetic wave travels in vacuum along z direction. What can you say about the direction of the electric and magnetic field vectors if the frequency of the wave is 30 million hertz? What is its wavelength? Okay, so if you remember that when we say that wave is traveling along x-axis, electric field is along y-axis, then magnetic field will be along z-axis, right? So they all should be mutually perpendicular. So here wave is traveling along z direction. If wave is along z direction, then we can take electric field along y-axis and magnetic field along x-axis, correct? Now next point is, if the frequency of wave is 30 million hertz, what is its wavelength? So what is formula? C equal to nu lambda, right? Where C is the speed of light, 3 into 10 to the power 8 equal to, frequency is given here 30 into 10 to the power 6, right, into lambda. Our concern is to get lambda. So lambda equal to 3 into 10 to the power 8 whole divided by 30 into 10 to the power 6. So it will become 10 meter. Question is simple. Now next question is, a radio can tune to any station in the 7.5 million hertz to 12 million hertz band. What is the corresponding wavelength band? So again, this is based on same concept. So as we have seen, C equal to F lambda. So we need lambda 1 C upon F1, 3 into 10 to the power 8 divided by what is F1. So it is 7.5 into 10 to the power 6 meter. You can evaluate it. And then comes lambda 2. So lambda 2 will be C upon F2. So C is same, 3 into 10 to the power 8 divided by frequency is given 12 into 10 to the power 6, and this will be in meter, correct? So you can easily evaluate. Now we are going to see next question. Next question says a charged particle oscillates between its mean equilibrium position with a frequency of 10 power 9 hertz. What is the frequency of electromagnetic waves produced by the oscillator? Obviously, frequency will not change, it will remain 10 power 9 hertz. So answer to this question is question number 8.6. So frequency nu will be 10 power 9 hertz. Question number 8.7. What does it say? The amplitude of magnetic field part of harmonic electromagnetic wave in vacuum is B0 equal to 510 nanotesla. What is the amplitude of electric field part? So I think you remember the relation E0 upon B0 gives C. So E0 will be equal to C times B0. We can put the values 3 into 10 to the power 8 multiplied by B0 is 510 nanotesla. So 510 multiplied by 10 to the power minus 9, and this will be Newton per Coulomb, right? It is simple to evaluate. Next question is, suppose that electric field amplitude of an electromagnetic wave is E0 equal to this much and frequency is 50 million hertz. Determine B0, omega, K, lambda. Find the expression for E and B. Right. So here this is an important question. We are given E0 equals, E0 is 120 Newton per Coulomb and frequency is given as 50 into 10 to the power 6 hertz because it is given in million hertz. So now determine B0. So I told you the formula. B0 is E0 divided by C, that is 120 divided by 3 into 10 to the power 8. We can evaluate it. 40 into 10 to the power minus 8 Tesla, right? Then we need omega. What is omega? What information is given? Omega equal to 2 pi divided by T, right? And here 1 upon T will be nu, so 2 pi into nu. So 2 pi into nu is given as 50 into 10 to the power 6. 50 into 10 power 6, correct? So we can get omega radian per second. I'm not evaluating, that you can do. Then comes K. What is K? K is 2 pi by lambda. Here we are given nu. If you remember, C equal to nu lambda. So if you want to find out 1 upon lambda, for that it will be nu divided by C. Is it okay? Lambda will come over here and C will go over there. So here we need 2 pi. So we can say it will become 2 pi and then nu divided by C. And 2 pi nu is this much. C is 3 into 10 power 8. From there we can get the value of K. So that is obvious. And lambda we have, if we have not evaluated lambda, so we can easily evaluate C equal to nu lambda. From here we can get that value, because C we know 3 into 10 power 8 and nu is given 15 to 10 power 6, and then lambda can be evaluated, and from there 1 upon lambda can be found. So now next point is find the expression for E and B. So here suppose that electric field component is given, and here direction is not mentioned. So if we assume that wave is traveling along x-axis and magnetic field is along z-axis and electric field is along y-axis, so we can use E equal to E0 sine omega t plus kx, or just reverse, we can write kx minus omega t. Both possibilities are possible if it travels along negative axis or along positive axis. So we will decide that later on. Here just we are taking that it is sine kx minus omega t, and here we take it along, say it is vector, so it will be along j cap, and magnetic field can be written as B equal to B0, same expression kx minus omega t times this is along kk, right? Where B0 we have already evaluated E0 divided by C, right? And E0 is this much, and we can divide, and K, as I have told you, it is 2 pi by lambda. We can easily evaluate, and we have already evaluated it. Omega, this is 2 pi by T, and T is 1 upon T equal to frequency, and then we can put these values. So these will be the expressions. Now let's see next question. Next question says the terminology of different parts of the electromagnetic spectrum is given in the text. Use the formula E equal to h nu for energy of quantum of radiation, photon, and obtain the photon energy in units of eV, electron volt, for different parts of electromagnetic spectrum. In what way are the different scales of photon energies that you obtain related to the source of electromagnetic? So this is simple question. Actually, what all you have to do, I'm giving one example. First of all, you will find E equal to h nu. Suppose nu is given as 10 power 15 hertz. Then what will be energy? 6.6 into 10 to the power minus 34 value of h into 10 to the power 15 joule. Now we need this energy in terms of electron volt. So energy, let's write electron volt EV will be equal to, or we can, if we don't want to write here like this, then we can write it 6.6 into 10 to the power, this will become minus 19 divided by electronic charge 1.6 into 10 to the power minus 19, then this answer will be in electron volt. Because if you remember, I told you 1 electron volt equal to electronic charge times 1 volt, that gives 1.6 into 10 power minus 19 joule. So this value is converted into electron volt. So here no more data is given, so you can assume like this, and for this you can refer your textbook. Next question is, In a plane electromagnetic wave, the electric field oscillates sinusoidally at a frequency of 2 into 10 power 10 hertz. So here in our question, value of nu is given, means frequency is given, and amplitude is given. Electric field, amplitude of electric field is given. What is the wavelength of the wave? We can find what is the amplitude of the oscillating magnetic field, so that average energy density of E field equals the average energy density of B field. So let's analyze these things. So for this purpose, what we can do, here we have to find out wavelength, frequency is given. So we know formula C equal to nu lambda, or lambda equal to C upon nu. So C is 3 into 10 to the power 8 divided by nu is given as 2 into 10 power 10. So this will give 1.5 into 10 to the power minus 2 meter. Correct? Then what is the amplitude of oscillating magnetic field? You know, magnetic field will be, suppose it is B0, so it will be E0 divided by C, and the value of E0 is given as 48 divided by 3 into 10 to the power 8. This will become 16 into 10 to the power minus 8 Tesla. Then, so that average energy density of the E field equals the average energy density of B field. So for this purpose, we can start with average energy density of E field. So UE 1 by 2 epsilon naught E0 square. This is average energy density of electric field. Now we have to convert it in terms of average energy density in magnetic field. So for that, what we can do? So here directly we should not write UB here. Let's convert it by E0 equal to C times B0. We replace this E0 by this value, and one more concept we have to make use, C equal to root of mu naught epsilon naught, and let's see what do we get. So UE, we are starting with the UE is 1 by 2 epsilon naught times E0 square, that is C square B0 square, but C square will give 1 by 2 epsilon naught, C square will give 1 upon mu naught epsilon naught times B0 square, right? And then epsilon naught will cancel out, and we will be left with B0 square divided by 2 mu naught, and this is energy density in magnetic field. This is UB. So we have got the answer. Now this is all numericals are done. I think you have understood. Thank you for watching. Team Educate.